Hey, Mr. Simon here. So I finished up my program for the create task, and now I want to finish the write-up and submit it. Now, you've seen my smiley face program before in some other videos. I've added a little bit here. So just to be on the safe side, I want to make sure I got some logic. Logic in programming is any sort of statement that evaluates to true or false. So if you have a loop or an if statement, you're going to have some logic in your program. I wanted to put in an if statement into my smiley face program, and I decided to use random. Random's not super important here. I just needed some sort of if statement that had something that evaluated to true or false. But what happens here in my program is I'm using random to randomly change the color of my smiley faces from green to yellow. You can read about the random function in the reference for P5. If you call random without any arguments, it's going to give you a decimal from 0 to 1. They call that a floating point number, which is a fancy way of saying a decimal. So I'm pretty close here to having a 50-50 chance of having a yellow or green smiley face. Now in 2C, I'm going to need to write about the algorithms in my program. And to get full credit, I want to choose an algorithm that's important. It has at least 2 other sub-algorithms, and at least one of those algorithms, either the main or the sub-algorithms, has to have math or logic. So for my main algorithm, I'm going to talk about my draw function. So my draw function draws 2 smiley faces at 2 different locations. An algorithm needs 2 or more steps. This has 2 steps, so I'm good there. And then I have sub-algorithms. Each call to the smiley face function in turn calls 2 other functions, head and face. And the head function has an algorithm inside of that sets the fill color and draws the ellipse. And the face function has an algorithm inside that. It draws an arc, sets the fill to black, and then it draws the 2 evenly spaced eyes to make the face. Now in my write-up here, I'm calling attention just to make sure the grader knows that I'm using math because I'm doing geometry. I'm writing or drawing shapes using XY coordinates. I'm also adding and subtracting. That's math to get the evenly spaced eyes. And I'm using random. That counts as math as well. Any of those would count as math. I only need math or logic, but just for the heck of it, I'm going to point out to the reader that I am using logic because I have an if statement that evaluates to true or false. Now for 2D, I have to show and explain an abstraction. Now, to get full credit for this, I have to choose an abstraction that I wrote. A good rule of thumb is that means I chose the name. If you're using an abstraction where the name had already been picked for you, that means it's a built-in abstraction. So an abstraction is typically going to be a function. So, ellipse is not going to be an abstraction that you wrote, right? You didn't choose the name ellipse, but face, that's an abstraction I wrote because I chose the name face. Now for this one, we have to use math and logic, and we need to show that it manages the complexity in our program and it's important. So examples how you might use a function to manage complexity are it'll save you copying and pasting. Rather than copying and pasting code, you can just call that function. It also breaks the program up into parts, making it easier to find the part that has the problem, easier to understand. And it makes it easier to read through the code, right? It makes it easier to find the part of the program that you want to modify or change if you're trying to make the program do something different or you're trying to fix a problem. So if you don't have a function that manages complexity in your program, at this point you're going to want to go back and write one because you're not going to get full credit unless you do. If you're not sure how to do this, you might ask some of your friends. As a teacher, I can't give you an advice on this. But in my program, I'm going to say my head function is the one that manages complexity. I have other functions that manage complexity, but the head function's got the logic in it as well as the math. It's got math because I'm graphing geometric shapes, and it's got math because I'm calling the random function, and it's got logic because I'm doing a comparison that evaluates to true or false inside the if statement. So here's what I wrote. I wrote that my abstraction in my program is the head XY function. It's important because it manages complexity. I can make as many heads as I want without having to duplicate the code that generates the random fill and calls the ellip function. It also makes it easier to debug. I mean, if the heads aren't coming out right, I know I'm going to look in the head function and not in the face function. And then I'm calling attention to the fact that I'm using math and logic just to give the grader a heads up. Now, once I've got this, I want to put all my answers in the create template, and then I want to save it as a PDF. And then I'm also going to need to save my code as a PDF and then create a program or a video of my program running. I recommend using Screencast-O-Matic for the video. It's pretty straightforward. I think you'll find it works pretty well. Maybe the most important thing is pay attention to when you're saving it, because you're going to have to go and find it later. Give it a name. Don't put your name here. All your submissions are supposed to be anonymous, but certainly okay to call it create task. The default type of MP4 is fine. And then when you're done here, just, click on publish. And for the folder, click a place where you're going to be able to find it. A lot of people save things to the desktop. If it were me, I'd save it to my videos folder. So then once you've saved that, you should be able to go back and find it. It's going to be like create task.mp4, and that's what you're going to need to submit. There are some word count limits here. If you click and select your code, you can also often find a word count. But most people aren't going to run into too much trouble getting their stuff in the word count limits. Finally, we need to submit a PDF of our program code. Now, for this, I'm going to suggest CodePrint. CodePrint was designed just for this. So it's going to make it really straightforward to you to get your code in. So the first thing you got to do is mark your ovals for your algorithms. So over here, there's going to be a pull-down menu that gives you a choice between ovals, or the first oval, or oval 2 or 3. And then you just click on the drag to put those ovals there. Once you put an oval, if you don't like it, you're going to get a menu choice here, clear oval or clear all. And then you can go back and do it until you like it. So here I've marked my ovals for my draw function, for my head function, and for my face function. Then you're going to need to mark a rectangle for your abstraction. Now, in my case, my abstraction is the same as one of my algorithms. That's fine. It's actually not unusual. The algorithm is the steps that are inside the function. The abstraction is the function itself. So if you have a rectangle and an oval that cover the same code, you're fine. Not a problem. Don't worry about it. So once you got that, you're going to be ready to submit. To submit with CodePrint, you're going to start by choosing print. Now, here's where it gets a little bit tricky. You want to, when the print dialog comes up, you want to make sure that you save this as a PDF. And click save it to some place where you can find it. And then you're all set to go. Now you can go up to your digital portfolio and you can upload those the 2 PDFs and your video. If there's any technical issue, don't worry about it. I'll check your submissions before the 26th deadline, and I can return them to you if you put the wrong files in the wrong place or there's a problem with the file format. So give me a heads up. Just make sure that you submit your work as final. Once you're submitted as final, you are done. Congratulations. And you are done with the AP Computer Science Principles course. Give yourself a high five and, celebrate as best you can. You've done a great job. Congratulations. All right. Thanks for watching. As always, send me an email if you got any questions.